Okay, you guys, so let's do a little bit more curve fitting. I did these three in an earlier video, and I'm going to come down here with the next three. And I'm actually going to do these two first because this one, there's a little bit more going on. So here what we're seeing is the absolute value of x graph for that one. And what it appears to be happening to this graph, a normal a normal absolute value of x graph will be going through 0, 0, 1, 1, and negative 1, 1. So a normal graph would look like this. So it looks like it's been shifted over to the right 4, and it's been shifted up 1, and there's no compressions or anything like that going on because these points here that I have in red match up with these points there. So everything has just been shifted right and up 1. So functionally this one would be f of x minus 4, and this would be f of x plus 1. So there's our f of x. So our y is the absolute value of x minus 4 and then plus 1. And so we can go to our graphing calculator, turn that sucker on. Oops, you can kind of see I've experimented with the last one. So let me go ahead and just clear that and clear that. And what we have is our absolute value graph. All right, that's the first one. And then the shift is the absolute value of x minus 4 and then plus 1. And so when I hit enter and graph, right, there's our normal curve. And then there it is being shifted over 4 and up 1. So we nailed it. So that's the picture that we're basically seeing. The next one, the basic function that we're looking at here seems to be x cubed. X cubed goes through 0, 0, 1, 1, and negative 1, 1, and pretty much has exactly that rippling effect that we see as we go on forever. So what's happening to this x cubed graph? Well, it looks like it went down 1, 2, 3, 4. So we went down 4, and then it looks like this point, or a 0, 0, went over 1, 2, 3. So we went to the left 3. And I don't see, again, matching these points, there doesn't seem to be anything mismatching. So there's no vertical compression or stretches. So down 4, well, that would be f of x minus 4. To the left 3, that would be f of x plus 3. So manipulating that into that function, we have y equals parentheses x plus 3 cubed and then minus 4. So there would be the function that fits this picture. Again, very easy to verify. Let me just clear that out, clear that out, and what we have is x to the third power. Right, there's our basic function, and what we're saying, this function we're seeing here is x plus 3 parentheses to the third power minus 4. Oops, be careful there. Got an arrow out of there. You go, minus 4. And so when we go graph that, there's our basic function that we're seeing, that we remembered, and then there's its picture that we're seeing there. So shifted to the left 3, down 4, no transformation, no vertical stretches or compression. So again, we're on solid ground. The next one, again, the basic function is x squared, right? It's very parabolic. The normal parabolic graph does something like this, going through 0, 0, 1, 1, and negative 1, 1. And so what I can see is it looks like this 0, 0 has been shifted down 1, and it's been shifted 1, 2, 3, 4, right, to the right. Okay? And then another thing that's kind of subtle here is the fact that it has actually been vertically compressed. Let me put that in red. And the reason I know that is because if this relationship right here was truly happening, right, we would be going through those 2 points there and the graph would be coming up. But it looks like it's not. It looks like it's been compressed. So, right, here's what we're going to do. So for this one, the function notation is f of x minus 4. This would be f of x minus 1, and this would be some a times f of x. So putting this all together with this function, we have y equals some a We know it's going to be less than 1 because we're compressed. X minus 4 squared, and then minus 1. So we now need to figure out what is that amount of compression that we have. And what we're going to do is something that's been happening a lot in your guys' homework. Let's take a data point like 0, 3 and use that data point to help us find that A. So when x is 0, the corresponding y value is 3. And so plugging in that ordered pair 0, 3 into the function that I have gives us the ability to solve for A. And I think I've seen that a lot on Canvas discussion boards. You guys have been doing really well with it, and we're using it. So negative 4 squared, that's a 16. So we're looking at 16a minus 1. If we add 1 to both sides, we get 4 equals 16a. Divide by 16, and we get a equals 1/4. So it is a compression, just like I thought. So this function that we're looking at is y equals 1/4 x minus 4 squared minus 1. And again, we can verify that by going to our graphing calculators. Let me get that glare out of there. Let me clear that. Let me clear that. And we definitely have x squared as our basic function. And then I like to use parentheses. So I got 1 divided by 4 in parentheses. Open up another set of parentheses. I have x minus 4 in those. And I'm squaring that. And then we're subtracting 1. And so when I graph that, we're going to see our basic function, right? There's x squared. And then here's that function being shifted over 4 and down 1 and going through the point 1, 2, 3, 0, 3. So we nailed it. So that picture, right, is that function. So that is a very valuable skill of our transformations. We're able to fit 6 different functions based off of pictures or based off of graphs. Again, it comes down to your ability to remember the basic function shapes, and then the new material is identifying the transformations occurring, what they mean functionally, right? And then you can basically put together the function together, just like we did in the last part of this module, or the first part of this module prior to this one. So there you have it, right? Well, obviously much more to do, much more to think about. We'll do that in some more videos coming soon.